Yes.
All right, we're trying to find the integral of this rational function. And this is, I can't just use u substitution right away, because if I could, I would have taken this bottom here and I would have called that u, but then the derivative of that is certainly not this, so that's just not going to work. And I can't make the top thing u with the bottom, because then I'd be dividing by, it just doesn't work. So what we're going to do is a long division. We're going to rewrite this so that we can use more of you're going to use like the reverse of the power rule of integration of derivatives. But then we're still going to have to probably use u substitution for one part of that rewritten expression. Okay, so let's just do long division first. So x squared plus 3 goes into x cubed minus 3x squared plus 4x minus 4. This goes into this x times. When I multiply, I get x cubed plus 3x. And I'm going to have to actually leave some space here, because 3x is actually going to be over here, plus 3x. Notice there's no x term there. So, and remember, I'm subtracting that. So when I distribute that negative in, it becomes, that goes away. It becomes negative, this comes down, negative 3x squared plus x minus 4. How many times does this go into this? Negative 3 times. When I multiply that into here, I get, remember I'm subtracting that, negative 3x squared, minus 9. And then of course distribute that back in, that goes away, this comes straight down, it's x, this adds down to plus 5. Now I can't put this into there anymore, so I'm done. So this becomes my numerator of my third part of my fraction. So x plus 5 over x squared plus 3. Okay? So in other words, what I just did, I can rewrite this fraction, this integral, as the integral of x minus 3 plus x plus 5 over x squared plus 3 dx. And why would I want to do that, you ask? Well, because now I can take the integral. Let me rewrite this. Oh, sorry, I realized I wrote this problem wrong before I keep going. This here should have been a 9, not a 4. So that's minus 9, so that's minus 9. So actually the 5 is not even there, which doesn't really make too big of a difference, but I guess it does help a little bit. So now when I redo this, so the whole point of that is now I can rewrite this right here. I can rewrite that as the integral of x dx minus the integral of 3 dx plus the integral of x over x squared plus 3 dx. I'm breaking it up. That's the point of it. This is just x squared over 2. Right? This is just negative 3x. And now for this one, I'm still going to have to do some fancy finagling, but now I can do it because what's the derivative of x squared plus 3?
2x.
It's 2x. So now I can use u substitution. So now I'm going to let u equal x squared plus 3, which means du equals 2x dx, which means 1/2 du equals x dx, which I can see right here, right? There's x dx. So I'm rewriting this as plus, I'm rewriting this as 1/2 of the integral of 1 over u du, which of course just equals 1/2 of ln of the absolute value of u. Don't forget I need the plus c at the end of all this stuff, right? Which means that just equals, plus, redo this, plus 1/2 ln of x squared plus 3 plus c. That was that last part. And then of course, don't forget you still have the 3x and the x squared over 2. So that's your answer.